Importance of telescope. Imagine being able to explore the universe, observe the formation of stars, and look beyond our own galaxy. What if we told you that a space telescope makes all of this possible? As we explore the essential role that space telescopes play in advancing astronomical science, come along on a voyage around the cosmos with us. A telescope in space, used to observe celestial objects, is known as a space telescope or space observatory. The American Orbiting Astronomical Observatory, OO2, launched in 1968, and the Soviet Orion 1 ultraviolet telescope aboard space station Salyut 1 in 1971 were the first operational telescopes, both of which were proposed by Lyman Spitzer in 1946. Space telescopes do not experience the light pollution that ground-based observatories do, nor do they experience the filtering and distortion, scintillation, of the electromagnetic radiation they detect. The two main categories of satellites are those that map the entire sky, astronomical surveys, and those that concentrate on certain astronomical objects or regions of the sky and beyond. Space telescopes are separate from Earth imaging satellites, which are used for weather analysis, espionage, and other sorts of information gathering. These satellites look towards Earth for satellite imaging. Why do we use space telescopes? In order to acquire a clearer view of the planets, stars, and galaxies that we are researching, we launch telescopes into space in order to avoid the Earth's atmosphere. Our atmosphere functions as a shield, allowing some light to pass through while blocking others. This is generally a good thing. If we were constantly exposed to high-energy X-rays or gamma rays outside, no amount of CVF would be able to shield us. But because of this protection, we are unable to gather those types of light for use in ground-based research. The atmosphere won't precisely comply with our request to make any extra accommodation for the light we want to see in our telescopes. For hundreds of years, astronomers have used telescopes to observe the night sky. The telescope must be in orbit to obtain the best data. The Earth's atmosphere is to blame for this. As a result of light bouncing about in the air, photographs may appear hazy. Moreover, it functions as a blanket, allowing some wavelengths of light through while blocking others. This implies that not all of an object's light is visible to us. Moreover, telescopes in space are away from Earth-based artificial light. This makes it challenging to observe dim objects from the ground. This is known as light pollution. The creation and operation of a space telescope is extremely difficult. It is also very expensive. It's only now feasible because of the 1980s. The Hubble Space Telescope is one of the most well-known space telescopes. It started observing in 1990 and has since captured more than 1 million photos. There have been numerous additional space telescopes since 1990. Some capture light that the atmosphere of the Earth prevents, like Fermi, who studies gamma rays, and Chandra, who studies X-rays. Others are able to perceive infrared or microwaves. This has changed the way we see the universe. James Webb Space Telescope, the largest, will launch in December 2021. Fantastic discoveries have been made by space telescopes. Kepler discovered a huge number of exoplanets. The first exoplanet light was captured by Spitzer. A supernova was seen by Gaia outside the Milky Way. LISA will aim to find gravitational waves in the future. Importance of space telescopes in astronomical research. Astronomers may study the cosmos with the help of space telescopes, which give them unmatched access to the universe. Space telescopes are not impacted by atmospheric turbulence, which can cause visual distortion and blurring, unlike ground-based telescopes. This makes it possible for space telescopes to take crystal-clear, high-resolution pictures of distant celestial objects. Additionally, a variety of wavelengths that the Earth's atmosphere blocks or absorbs, such as X-rays, ultraviolet light, and infrared radiation, can be used by space telescopes to study the universe. This makes it possible for astronomers to thoroughly investigate a range of celestial objects, such as planets, stars, galaxies, phenomena that happen at any time of day or night, Because space telescopes can observe continually without being disrupted by daylight, our knowledge of the universe has been fundamentally altered by the data gathered by space telescopes, which have provided fresh perspectives on the universe's beginnings, the nature of dark matter and dark energy, and the long-term history of galaxies. Space telescopes are therefore essential tools for improving astronomical study and enhancing our understanding of the cosmos. The telescope of the future. Refracting telescopes faced distinct issues than the reflecting telescopes created in the 18th and 19th centuries. While making tin and copper alloy mirrors was simpler than grinding lenses, these metal mirrors tended to tarnish, necessitating frequent polishing. A physics issue was also encountered by the astronomers. Scientists found the enormous devices challenging to transport due to the size of the mirrors and the telescopes that held them. It took some time and effort to shift the field of view to a different region of the sky. Midway through the 1800s, astronomers came to the conclusion that the atmosphere, not the telescopes, was the reason why distant objects continued to appear foggy. Scientists discovered that light bends in surprising ways as it travels through the atmosphere. This is what causes stars to appear to twinkle to the unassisted eye. But using a telescope only causes images to appear hazy, similar to how things appear when you stare up from the ocean. The inability to focus on distant images was the issue that inspired the creation of the Hubble Space Telescope. What makes Hubble different from telescopes on Earth? The atmosphere of a planet is the collection of gases that surround it. Some of the light that arrives from space is blocked by variations in the atmosphere on Earth. Far above the Earth and its atmosphere, Hubble travels and orbits. So, Hubble has a better view of space than telescopes on Earth do. You cannot use a telescope like Hubble to view objects with your eyes. Using a digital camera is straightforward. Like a cell phone, it can snap images. The images are then transmitted back to Earth by Hubble using radio waves. What is NASA learning from the Hubble Space Telescope? Hubble has aided scientists in their understanding of the solar system. Comets and planets are observed by the telescope. Even previously unseen moons surrounding Pluto were found by Hubble. The telescope has aided in the understanding of galaxy and planet formation. There are billions of stars and galaxies. A photograph called Hubble Ultra Deep Field displays some of the furthest galaxies ever observed. Hubble images aid in the scientific understanding of the cosmos. Scientists estimate that the universe is almost 14 billion years old based on Hubble's images. Black holes have been found by Hubble. Black holes absorb everything in their vicinity, even the light sucked in. And Hubble has aided researchers in their understanding of the explosions that take place when massive stars die. In conclusion, space telescopes have transformed how we perceive the cosmos and created new opportunities for astronomical study. With its astounding sensitivity and extensive coverage, the Cherenkov Telescope Array promises to delve even deeper into the cosmos mysteries. Astronomy is in a thrilling period right now, and we can only speculate about the new discoveries that will be made in the upcoming years. Remember to follow our channel so you won't miss any